Have you ever sat down and truly pondered how a computer works? As we delve into this question, we're going to uncover the mysteries that lie within these ubiquitous machines. From the silent calculations happening at lightning speed to the seamless communication between different components, there's a lot more to a computer than meets the eye. So, if you've ever found yourself intrigued by the marvel of modern technology that is the computer, you're in for a treat. Well, prepare to dive into the fascinating world of computers. At the heart of every computer, you'll find the Central Processing Unit, or CPU. This unassuming piece of technology, often no larger than a postage stamp, is a powerful engine that keeps our digital world turning. So, what exactly is the role of the CPU? Well, imagine the CPU as the computer's mastermind. It's tasked with executing a series of commands that make your computer function. Everything you do on your computer, from typing a document to playing a video game, requires the CPU to process a series of instructions. The CPU operates by following a set of instructions known as a program. This program is stored in the computer's memory and tells the CPU what to do. When you click a button or type a command, the CPU retrieves the relevant instructions from memory and carries them out. But here's where things get interesting. The CPU doesn't just execute one instruction at a time, it can handle multiple instructions simultaneously. This is known as multi-threading. The more threads a CPU can handle, the faster and more efficient it will be. Now you might be wondering, how does the CPU know which instruction to execute first? This is where the CPU's control unit comes into play. The control unit directs the flow of data and instructions within the CPU, ensuring that each process is executed in the correct order. The CPU also includes an arithmetic logic unit, or ALU, which performs all the mathematical and logical operations. Whether you're calculating a spreadsheet or shooting aliens in a game, it's the ALU that's crunching the numbers and making it all possible. The speed of a CPU is measured in hertz. A CPU with a speed of 1 GHz can process 1 billion instructions per second. That's an astounding amount of information being processed in the blink of an eye. So in essence, the CPU is the brain of the computer, making all the high-level decisions. It's a marvel of engineering that allows us to interact with the digital world in ways that were once unimaginable. Without the CPU, our computers would be nothing more than lifeless boxes of metal and plastic. Just like humans, computers also have memory, but in the form of RAM and storage. So, let's dive into the world of computer memory, where we'll explore the roles of RAM and storage, and understand how these two critical components work together to keep our computers running smoothly. RAM, or Random Access Memory, is a type of memory that's used to store data that the computer is currently working with. Think of it as a workspace or a temporary holding area where your computer can quickly access the information it needs. If you're working on a document, browsing the web, or playing a game, all the data needed for these activities are stored in the RAM. Now, you might wonder, what happens when the computer is turned off? This is where storage comes into play. Unlike RAM, which is volatile, meaning it loses its contents when power is lost, storage is non-volatile. It holds on to data even when the computer is switched off. This is the place where all your files, documents, music, and movies are stored. There are different types of RAM and storage, each with its unique characteristics. For RAM, we have static RAM and dynamic RAM. Static RAM is faster and more reliable, but it's also more expensive. On the other hand, dynamic RAM is less expensive but slower and less reliable. When it comes to storage, we have hard disk drives and solid-state drives. Hard disk drives, or HDDs, are the traditional form of storage. They're slower, but they offer more storage capacity and are less expensive. Solid-state drives, or SSDs, are the newer, faster form of storage. They're more expensive, but they work much faster than HDDs, making your computer more responsive. Understanding the roles of RAM and storage and their different types and capacities can help you make informed decisions when buying or upgrading a computer. It's like knowing what kind of engine and gas tank you need for your car. Hence, RAM and storage serve as the computer's memory, holding on to information both temporarily and long-term. The computer has a way of talking to the outside world, and that's through input and output devices. Imagine yourself at a party where everyone speaks a different language. It would be quite challenging to communicate, wouldn't it? Well, that's how a computer would feel if it weren't for input and output devices. They are the interpreters at this hypothetical party, converting our language into one the computer understands and vice versa. Let's start with input devices. Think of them as the computer's ears and fingers. The keyboard and mouse are prime examples. When you type a letter or move the cursor, you're essentially whispering instructions into the computer's ear. These devices capture our physical interaction and translate it into data the computer can process. Now let's talk about output devices. These are the computer's voice and face. The monitor, for instance, serves as the computer's face, displaying the results of our commands in a visual format we can comprehend. It's like the computer is drawing a picture or writing a message to convey its response to our instructions. Then we have speakers, the computer's voice. They transform digital audio files into sounds we can hear. Whether it's the chime that rings when you start up the system, or the music from your favorite playlist, it's all thanks to the speakers. These devices are crucial for human-computer interaction. Without them, we would be unable to instruct the computer or understand its responses. They bridge the gap between the digital world of the computer and our physical world, facilitating a form of communication that has revolutionized the way we live, work, and play. In the same way that our senses allow us to perceive and interact with the world around us, input and output devices provide the computer with a means to interact with its environment. They are not just peripheral devices, they are essential components that make computers interactive, engaging, and useful. Input and output devices, therefore, are the computer's means of communicating with the user and the world. How does a computer connect its various parts together? The answer lies in the motherboard. This humble component, often overshadowed by the more flashy parts like the CPU and the GPU, plays an integral role in making a computer what it is. Think of the motherboard as the main circuit board of a computer. This is where you'll find slots for the CPU, memory, and other essential components. It's the primary communication hub, the grand central station where all the other parts of the computer come together and interact. The motherboard is like the city planner of a computer. It lays down the groundwork, marking out where everything goes and how they connect to one another. It ensures that power is distributed evenly, that the CPU and memory are in sync, and that all the peripherals like your keyboard, mouse, and monitor are properly connected. The motherboard is also responsible for system management. It oversees the smooth operation of the other components, ensuring that they're functioning at their best. It's the motherboard that facilitates the communication between the CPU and the memory, or between the hard drive and the graphics card. This circuit board is also the one that decides how fast your computer can go. The speed of the bus, which is the data pathway on the motherboard, determines how quickly information can travel between different components. The faster the bus speed, the more quickly your computer can process and retrieve information. The motherboard, despite its unassuming appearance, holds the power to make or break your computing experience. It's the unsung hero that works behind the scenes, ensuring that all the other parts of your computer work together seamlessly. So, the next time you use your computer, remember the crucial role played by the motherboard. It's more than just a flat piece of circuitry. It's the heart of your computer's communication system, the grand orchestrator that makes all the magic happen. The motherboard is like the computer's nervous system, connecting and facilitating communication between all the other parts. So, now you have a basic understanding of what makes a computer tick. It all starts with the heart of the machine, the central processing unit, or CPU. This is where all the computing happens, where all the decisions are made. It's the brains of the operation, if you will, and it's responsible for executing the instructions that make your computer do what you want it to do. Next, we delved into the realm of memory. We have the RAM, or random access memory, which serves as the computer's short-term memory. It's volatile, meaning it forgets everything once the power is off. Then we have the storage devices like hard drives and solid-state drives, which serve as the computer's long-term memory, retaining data even when the power is turned off. Then, we have the communicators, the input and output devices. These are the ways the computer interacts with the world, how it receives data from you through inputs like the keyboard and mouse, and how it sends data back to you through outputs like the monitor and speakers. And finally, we have the motherboard, the great connector. This is the hub where everything comes together. It's where the CPU, the memory, and the input and output devices all connect and communicate. And there you have it, a brief overview of how a computer works, a marvel of modern technology, wouldn't you agree?